Okay, so welcome to the stream. If there are anyone out there, which they aren't, because I would know. So I always start this scream by at least stream, by spamming some, at least like my Twitter or some Discord or something. But so it's always a bit painful to start because I like just getting the link for the stream is something I probably should find if I do like a search for how to find a link in OBS, but I really am not that thoughtful about things. So you're probably just gonna wait. But yeah, I got the link. I got the link. And I'll spam my Twitter. Working on an experimental hot end extruder thing. Okay. So the let's talk about this extruder thing. So if you notice in the picture or the thumbnail, which I can obviously just bring up here, which is kind of just like some fun stuff that I did. So this is something I'm working on for like a YouTube episode, which is about the main, like the most important thing in 3D printing that probably most people overlook and never think much about. And that is the melting of plastic, basically, and the technological phenomena or the phenomena which are harnessed and put to use in the 3D printing technology. And this is like if this fail, everything else will fail. So everything else is just to support and make this specific process useful, and that is the melting of plastic, like making a material soft by or liquid by heating it, and then to generate a pressure differential inside the melting chamber, and then it will take the path of less resistance, which is through the nozzle. So in this process, this is like if this gets messed up, then yeah, you're basically screwed. So I just want to kind of make a video where I can point to these specific things while I'm working on a 3D printer that I'm gonna build. So yeah, that's it. So for the experiments, I will be running. So what I want to do is I'll just start. So this is like I'm not totally sure how I'm gonna do this. So I don't have like a plan. Just like see parts of the design, so to speak, in my head. So what I'm seeing is, let's say, about 30 millimeters. And we'll do that. Yeah, I'm also gonna make a line here. So these will be wheels. 30, and then we'll do another 30 here. And then we need to have the same distance to this point at least. So yeah, I could do that, but that's like not that useful. So it's going to be so just gonna make it in a stupid way, or like in a way most people would say like, oh, that will not work. And that is, I'm going to 3D print the hub gears or the gears that pushes the filaments. And I want to just say, you know, I like to just use the dumbest solutions or ways of designing things. And see if it works. And if it doesn't, which is usually the case, that's fine. And I will be running some 5mm screws through these, and I'm going to use a bearing, which I actually don't have here, but I'll find it. Which is, oh, it's actually this, which is which are the wrong one, and what the? I'm probably doing something dumb now. Oh yeah, I'm actually not. It's like 5 it doesn't work. Yeah, that's weird. Because like I should be able to just hit 5 and it should work, but it doesn't. Let's D. What? Like this is messed. What the? I'm writing, but nothing is happening. I don't understand. If I hit 5, so can I write 5 in other? Yeah? Yes, I can. Okay, can I write 5? Can this be turned 5? What? But, okay. Now it worked. Oh, that was weird. Okay. So, let's just bring up the browser window so you can see what I'm searching for. Open builds mini wheels. And we're gonna use the bearings from these mini wheels, which are, I don't remember, I never. So they're called, like, oh, can it, 105ZZ, ZZ. Yeah, there they are. Let's get the dimensions of these. There. 5, 10, 4. Okay, that's fine. So I usually on bearings use 0.15mm as clearance, which seem to usually work. There, and the thickness is 4mm, which is nice. So let's just extrude these. Yeah, that direction is fine. I kind of like to make things look like bearings, if they aren't, but I'll try not to do that now. And these are going to be, it's like, what's going on now? 4. I select this, nothing is happening. Is it not closed? It's not closed. What's going on? That one is closed. Okay, I'm gonna get the visitors. My son just jumped in, so I'll just be right back. Okay, so I'm going to... I'll probably redo this. That's fine. So I need to make a profile, another sketch, which will be... Hang on. Yeah, I got my son still here.
Hello, guys.
So let's actually I'm gonna just redo everything because now I needed these origin points. 30, 30, 10, 5, 30, 10, 5. And we'll tangent them to the origin plane. There, there. And we'll put it to down here and down there. There. So that's going to make it a lot easier to do what I'm going to do next. So I'll be creating a sketch here. That was wrong. I'll be creating a sketch on this one. There. So the filament that I'll be using, at least for this experiment, is going to be 185 or 285. And that usually runs in the tube, which are like 3mm. But we'll just run with 285. Now, yeah, this is fine. Let's finish off this. Now we'll just extrude these. I'll do a symmetric extrusion so we can easily change in both directions later. Oh, 2mm. Like this. And let's create 2 revolves. So one like that. And another one. Oh yeah, not extrude, that's wrong. There. And another one like that. Okay. That's fine. So now the filament could be stopped by these two wheels bumping into each other. So we'll be adding a square rectangle, which is, let's say, to 1.5. And we'll run a revolve for this as well. And same axis. So something I'm going to test is that, like, at least in my head, theoretically, you should be able to not have a like a cold part of your extruder, like the heat break and all that stuff. So I'm going to try that. And when it fails, because it's obviously going to fail, because or else it would be made like that for a long time ago, and we'll figure out if it's possible to solve it in another way. Because I'm quite interested in this. There you have it. Now, for some reason, I was dumb enough to think that I was going to have a bearing in these, but these are driving gears. You obviously don't have that. Let's do a dual or symmetric extrusion like that. Okay. So now comes the the hard part. How will I be driving this? Okay, so because this is just a test, I'm not going to care that much about that. What I'll be doing, so I'm actually going to run this on like a very small stepper, like a low torque, very small stepper. And I'm actually going to get that stepper, I think, now, because I need the measurements for it. And yeah, I guess it'll just be silent for like a few minutes while I run and get it. And I'm back. Okay, so let's get the browser window back. So this, we'll get the part number for this. Yeah, it's from Steppery Online. And it's called H8HS 15-0604S. So, yeah, it's none of these. This is a NEMA 8 motor. So like the smallest motor ever. And the reason why I want it to be small is that I'm going to use it to measure with. So I'll be supervising the current it draws. Or that's not really how it works. So I'll be changing the current on the stepper motor via code. And then I'm going to check the load angle if it's out of sync. Because obviously stepper motors usually just run on the power that they get. But you can check the load by checking the load angle from like a proper motor controller, like the TMC 5160 from Trinamic. So let's get these measurements. First of all, let me just check the. Actually, hang on. There, I bet like $1,000 that there's no one in the chat. But I think I should pull out the chat window just in case. Yes, it's like I thought, completely blank. But that's fine. That's how it is to start something new. I just saw like a stat doc thing here, so let's get that as well. Cool. Okay, back to the motor. What's the max current I can use here? Or, yeah, 0.6. Oh, that's fine. That's fine. 600 milli is about the same as a stock, like Ender 3, I think, run on max power. It's like something like that. We're close. So this motor is pretty long, as you see. So that's probably why it can handle a lot of current compared to its size. And this is exactly the reason why I'm going to use it. The shaft is a bit small, but that's fine. We'll fix that. So let's get this. So it's 20.3. I'll probably move this around. Let's create another sketch. 20.3. Usually I just go to GrabCAD and just pull something off there. And then it's 15.4. The screw holes. Or the mounting holes. Or 4? Was it 4? Ah, 15.4. 15.4. 15.4. I think I should start to stream to Twitch because it has better algorithmic sharing. Or maybe I can do both. I think I've done that once, like at least set it up. Oh yeah, I have this window there. Let's get it so something like that. Okay, let's create normal extrusion for that one. And this is probably like 3mm. Depth, so 2.5. Yeah. My poorly calibrated 3D printer says this should be 3. or actually, no, not this time. 2.5 we need. Alright, no, we're gonna do 3. We'll just make the mounting plate a bit bigger. And what is the thing is 16. Like oh, okay. The shaft is 4. 4. And this one is 3.5, which means that it's 4 divided on 2 minus 0.5. Yeah, that's about right. So let's extrude the axle. In what direction? Yeah, the other direction. The axle is 10 point minus 10.1, and we'll just make a component of this. And this is minus 1.5 minus 1.5. This will be a new body. And what kind of rounded corner does this thing have? It doesn't say, but I bet it's like... I bet it's like 2, 3. It's probably less than 2. 1.5, I bet. There. Let's get out of the sketch. And the body is 38. Minus 38. Oh, this is not minus. Oh, someone is calling me. That's just my wife, hang on. Ah, I've been talking for like 10 minutes without the sound on. That sucks. Hey, but that's good. There's no one in the chat. But maybe someone will watch it later. Okay, let's just hide off the sketches. And we'll be driving these with a GT2 gear. Yeah. Yes, we are. And I have a belt, but I'm not going to care too much about that now. Or am I? Nope. We're not. So let's put let's make a new sketch on this here, and we'll make the bearings here. It seemed to snatch to the right place. So now, if both of these are going to go in the same direction, how? Or they will be actually in the opposite direction. How should I drive the gears? So if I'll just strap it from like here to up here, they will not go in the right direction. So there are probably some pattern here that I just can't come think about that many people know about, but I don't. Let's not try to be smart and just Google it. Driving gears, opposite direction, belt, pulleys. Yeah, obviously a cross belt pulley drive. This breaks my brain. Oh, I don't like this. There must be another way. There. This is something I had in mind, like nope, nope. Is there like a cross a belt drive alternative? Cross belt drive alternative. Dual. Hey, I think I might. No, I don't might. It's probably the only way, but I really don't like the looks of this. But I probably don't have a choice. Or if I have this will go in that direction, and I need something that goes in this direction. But I could obviously only drive one of them and just let one free roll, which is not ideal. Or I can have two of these, but I don't. Drive two belts with one motor, mother motor, synchron. If this goes in that direction, this will turn this way, and this will go that way. It's the same. Two motors. One motor, two pulleys. Sounds like a video from the old internet. Synchronized. So I could run it from both sides, like one on the other side. No, that's not gonna work. There's interesting. Config with fans running in opposite direction. That's what I need. That's like a double crust. But how do they cross these pulleys without like crashing them in each other? Opposite direction. Opposite direction pulley one motor. I'm happy I have Googled, so I don't have to be smart. Okay, now we're closing in. That looks... So engine outputs... Really? This is not right. That's the idler. Yes, okay. That's cool. That's cool. Because it goes on the back side. However, if you're going to use a GT2 belt for this, one is going to be very slippery, and the other one is not. But that might be fine, because it's better than to just have it free rolling. And you don't have the crossing. A twist in the belt reverses the direction of the pulley. Yep. Maybe that's a better idea to just twist the gears. But don't they just like crash into each other? How do you prevent that? Hmm, that's weird. This is probably another solution. Hum. So on this one, it's crossed. But it's like I need to see this in like in a non-drawing because I understand that it works, but I just like why don't they just like run into each other? Is it because of friction between these? Forward, reverse with a single gear. Forward, reverse with a single gear. Pulley. Huh. Let's go to YouTube if that's legal. Forward like crust roller, crust belt roller, crust belt pulley, pulley, opposite direction. Okay, so that's an animation. 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 What the heck is this? That looks very dangerous. Yes, yes, yes. I see that you have crossed belts. I want to see them in reality. Nope. Not that. It's all drawings. I think that no one has actually done this. It's all just a lie. No one has ever made a cross pulley. See? It's all drawings. See? It's like, yeah, oh, yeah, I get it. So, okay. But it's like, uh, is it at an angle? Yeah, it is. The entire belt drive thing seemed to be at an angle. That's how you do it. So that one. This is how it's done. It's like this is a robotic thing. Okay, so it has angled gears. Okay, that's interesting. Okay, I'll look more this up. I need to go take care of my kids now. So obviously, this is as far as we got. Filament will be threaded down here into the melting block, which will be down here. So that's it for this episode of this extruder. I might be able to work on this later today. We'll see. Bye.